Section 1. Most Kubernetes tools sit outside your cluster. They watch from a distance, they query your API server, they send you alerts. And then you, a human, have to log in, figure out what's wrong, and fix it. Kubepilot takes a completely different approach. It actually lives inside your cluster. It runs as a persistent pod. It's not an external observer, it's a tenant. And from that position, it can see everything your cluster sees, in real time. So what does it actually do? When something goes wrong, a pod enters crash loop backoff, a deployment fails to roll out, resource limits get hit, Kubepilot detects it. It then uses an AI model to reason about the issue. Not just pattern match on error codes, but actually reason, what's the likely cause, what are the available fixes, what's the safest action to take? Then, and this is the part that makes DevOps engineers either excited or nervous, it can act. It can apply patches. Restart pods. Adjust configurations. All from inside the cluster, using the permissions you've granted it. Let's look at a concrete example. You've got a Node.js service that keeps getting OM killed because someone set a memory limit of 256 megabytes and the service actually needs 512. Normally you'd get paged at 2 a.m., SSH in, look at the logs, figure out the limit issue, bump the config, redeploy. With Kubepilot running, it catches the OOM killed event, identifies the memory limit as the probable cause, proposes a patch to the deployment manifest, and if you've configured it with the right permissions, applies it all without you touching a keyboard. It integrates with your existing kubectl configuration. It has a logging interface that shows you everything it did and why. This is not a black box making silent changes. Every action is logged with reasoning attached. Section 2. Okay, let's be honest about what this is not. First, Kubepilot is not a replacement for a senior infrastructure engineer. It can handle a specific category of well-understood Kubernetes failures, things like OOM kills, crash loops, failed deployments. If your problem is architectural wrong service mesh design, a subtle networking misconfiguration that only manifests under specific load patterns, this tool is not going to solve that. The AI reasoning is only as good as the patterns it's been trained or prompted to recognize. Second, it is not autonomous in an unlimited sense. It operates within the RBAC permissions you grant it. If you give it read-only permissions, it can diagnose but not fix. That's actually by design, you control how much autonomy it has. But this also means that poorly configured permissions in either direction create problems. Too restrictive, it can't help. Too permissive, it can do things you didn't intend. Third, this is a relatively early-stage project. The GitHub repository shows active development, but it's not a mature, battle-tested production tool with years of enterprise use behind it. If you're considering this for a critical production cluster, you should treat it like you'd treat any new infrastructure component, test it in staging, understand its behavior, define its permission scope carefully. Fourth, the AI reasoning requires an LLM backend. You need an API key configured. There are latency and cost implications. For clusters with very high event volumes, you need to think about how events are filtered before hitting the LLM, otherwise you're burning tokens on noise. Section 3. Here's what I think could realistically happen with a project like this as it matures. The most immediate useful evolution is better scoping of what triggers AI analysis versus what gets filtered. Right now the risk in high-traffic environments is event noise. A smarter pre-filter layer that uses lightweight heuristics before escalating to the LLM would make this much more production viable. Something else that seems plausible, integration with GitOps workflows. Instead of directly patching a live cluster, Kubepilot could propose changes as pull requests to your Helm chart or customize config repository. The AI diagnoses, generates the fix, opens a PR, a human reviews and approves, and the change goes in through your normal CD pipeline. That's a much more comfortable operational model for most teams. Longer term, a project like this could develop cluster-specific memory. It observes your cluster over weeks, learns what's normal for your specific workloads, and gets better at distinguishing real anomalies from expected behavior. That kind of persistent, in-cluster agent has a genuine advantage over external tools for building this kind of context. There's also a multi-cluster management angle. One Kubepilot instance per cluster, coordinated through a central interface. For platform engineering teams managing dozens of clusters, that changes the operational math significantly. Section 4. So why does this project exist? Kubernetes is genuinely hard to operate. Not hard to get started with, there are great managed services now that abstract most of the control plane complexity. But hard to keep running reliably at scale. The failure modes are numerous, they often require specialist knowledge to diagnose, and they happen at times when no one wants to be debugging infrastructure. The standard response to this has been better observability. More metrics, better dashboards, smarter alerting. And all of that is real progress. But observability still ends at the human. You still need someone to look at the dashboard, interpret the signal, and take action. What Kubepilot is exploring is whether the gap between detection and remediation can be closed, at least for a category of well-understood problems. And the architectural bet it's making is that an agent which runs inside the cluster will be better positioned to do this than one that lives outside it. More context, lower latency, direct access to the same APIs and events that Kubernetes itself uses. Whether this specific project becomes the standard approach is an open question. But the core idea, autonomous, in-cluster remediation for common failure patterns, is a direction the industry is moving toward. Kubepilot is an early, honest exploration of what that looks like in practice. If you're running Kubernetes in production and you've ever been woken up at 3 a.m. for a crash loop backoff that could have been auto-resolved, this is worth watching. The GitHub link is in the description. And if you're deploying your own AI tooling, Kubepilot included, and need reliable, developer-friendly cloud hosting to back it, DigitalOcean is worth a look. They sponsor this channel and their managed Kubernetes service is genuinely solid for exactly this kind of workload. Link below.